Food is the fuel to our lives, but are we really consuming the healthiest food? My name is StaceySandy, and this project is for the fulfillment of the MSDS 692 Data Science Practicum 1 course at Regis University. To introduce this project, I will be working with the USDA's FoodData Central Data. An API will allow me to retrieve a variety of data from a specific data repository of my choice or from 5 available data types. As an overview, I will be conducting an analysis of nutritional labels for 2 types of food of my choosing, which will be on sticky rice and 100% whole wheat bread. I must warn you, keep in mind that the selections within this project are primarily random. It must also be taken into consideration that each human has their own unique health history, health needs, nutritional goals, and health focus. Everyone always follows their own diets and their own macronutrients. So the goal of the project is to first compare nutritional label data against related food products, as well as to see what we should be avoiding in relation to foods ranked by macronutrients. These are the 3 data sources that I will be using. A bit of history on the background of FoodData Central is that it was a means to bring together 5 different USDA websites and those data repositories together in a central location. So when you're searching foods through FoodData Central, your search is retrieving data from all 5 data repositories, and this also retrieves nutritional data. The 5 data types referred to from the USDA include foundation foods, which is nutrient and food component values on a diverse range of ingredient and commodity foods. Then there's experimental foods, which links to relevant agricultural research data from multiple sources, such as the Agricultural Collaborative Research Outcome System. And there's the SR Legacy, which I will delve into deeper when I look at the nutrient lists from the SR Legacy database. It was released back in April of 2018 and formerly hosted by the USDA Food Composition Database website. And this is actually the final release of this data type. The Food and Nutrition Database for Dietary Studies is from 2013 to 2014, contains data on nutrient and data component values and weights for foods and beverages reported in the What We Eat in America Dietary Survey component of the National Health and Nutrition Examination Survey. Lastly, there's the USDA Global Branded Food Products Database, which houses branded foods, and it's formerly hosted by the USDA Food Composition Database website as well. But it has a private and public partnership that provides values for nutrients in branded and private label foods, which appear directly on the product label. So I'll try not to bore you any further, but let me go ahead and just go through what I will be presenting as an overview. First, I'll start with the project research questions, and then I'll do an overview of the project process and the methods of retrieving data from FoodData Central. Don't worry, I'm not going to run you through the 300+ lines of code, but I will present visualizations of my exploratory data analysis and a comparison and contrast of my findings. And then I'll present 2 machine learning algorithms, which is a decision tree and a cat boost model. More importantly, I'll go through what is the highest macronutrition values from the nutrient lists of the standard reference legacy. As I mentioned, that was the SRL from USDA. And then I'll conclude with the project points of interest and then the lessons learned, and then we'll be done. All right, so the research questions at hand is, are we really making the healthiest food choices? What does nutritional value in food really mean? Are we eating nutritious food, or are we eating what is easy, fast, and cheap? is our food selection based on nutritional values or for other reasons? Who knows? But the primary question of this project is, what if we would look at the nutritional values of a type of food and then compare those values to see if our choice of food is the healthiest for us or if a healthier option is available. The methods of retrieving data from FoodData Central is 3 different ways. The most basic form of getting a list of foods and the nutritional data is to enter the food or the food type directly into the FoodData Central search bar on the USDA website, which is located here. And that will automatically give you a list of foods in your search criteria and the nutritional information. The other 2 methods of retrieving data from the FoodData Central is using an API. It's easily requested through the USDA website. Once you do so, you can actually access a list of food based on your search, and then the food details endpoint gives you the nutritional data on those foods. These 2 methods at using an API were the first few steps and the most lengthy steps at getting my data. Okay, so now for the fun stuff. Let's look at some visualizations for my exploratory data analysis. I know this is kind of rough to begin with, but we're going to go ahead and look at the correlation plot on the sticky rices. And just upon my exploratory data analysis, FoodData Central outputted 19 items related to my sticky rice food search and gave me nutritional information for each of those 19 food types. As you can see, there is an extensive correlation on nutritional information, such as the major correlations to point out is the calories to protein, which is located right here. And then we have the calories to carbohydrates and the calories to sodium, which follows. And then we have calories to fat and the calories to cholesterol. Okay, now let's look at the correlation plot on 100% whole wheat bread. FoodData Central actually only returned 5 items related to my 100% whole wheat bread search. And of those 5 items, as you notice, there is no trans fat, there is no cholesterol, and there is no potassium reported. This can indicate that those values need to be further investigated to see if there is in fact 0 trans fat and cholesterol and potassium in 100% whole wheat bread products, or are those nutritional values not reported and omitted for some other reason. But let's go ahead and just disregard that, and we're going to go ahead and focus on the higher correlations of calories to carbohydrates. Ooh, that was a big one. And then calories to saturated fat, calories to sodium, and calories to fat in general. I won't be going through every nutritional value and compare and contrast the visualizations, but it is easily accessible within my Jupyter notebook for those that are interested. I am primarily going to present those of interest and of value for the purpose of this presentation. So for this bar plot of the 19 sticky rice items that returned from the FoodData Central web search on sticky rice, we can see that the calories vary, and there are some very known anomalies such as tender beef with onions, and then of course grilled salmon. Then another one to mention is the crepes. Then these food items could be some sort of food that contains sticky rice ingredients, but what we are really looking for is just plain and this capitalized sticky rice item here with the 210 calories. Okay, let's go ahead and look at the whole wheat bread calories. The highest calories here is the private selection 100% whole wheat bread, white pan bread. This is actually my favorite, and it's at 120 calories. So we'll go ahead and look at carbohydrates to compare values as well. Carbohydrates of sticky rice is looking at 49, and as for the whole wheat bread, we have carbohydrates at a max of 23. Because sodium was such a high correlation for both sticky rice and 100% whole wheat bread, let's take a closer look at sodium. The sodium value for sticky rice looks like it's at 11.2 with this value item. And then let's go ahead and look at the sodium for whole wheat bread, which is the highest value is at 260. Wow. And then we'll go ahead and look at the fat value for the purposes of macronutrients. Looks like sticky rice, we have a value of 0, which is kind of hard to see because it's blocked, but it is at 0. And then we'll go ahead and look at looking at the whole wheat bread fat, we can see here that there is a value of 1.5. So let's go ahead and just continue on with the comparison and see that sticky rice has 210 calories, 49 carbohydrates, sodium at 11.2, and fat is 0. 100% whole wheat bread comes out at 120 calories, 23 carbohydrates, and sodium is 260, while fat is 1.5. So, which is healthier? Well, looks like 100% whole wheat bread is healthier than sticky rice. But which of the 5 breads that return from the FoodData Central is the most nutritious and healthiest? It seems to be that the honey 100% whole wheat bread is the healthiest with the lowest sugars, highest protein, and lowest carbohydrates. For my machine learning algorithms, my goal was to conduct a decision tree on my data and then run the data through a CatBoost model. I was hoping that the decision tree would help narrow down the parameters of the nutritional values for me and could possibly predict which food is healthiest. As for CatBoost, I was hoping that it would be able to predict caloric information for me. Unfortunately, I was unable to move forward with the decision tree because the Gini value of the data frame was so high. It showed a value which was 0.8775, which is close to 1, indicating the high impurity values of my sticky rice data frame. Again, unfortunately, the Gini for 100% whole wheat bread is negative at negative 1.36, which proves my machine learning decision tree methods for the whole wheat bread data frame is also ineffective. I'm sadly defeated by the decision tree capabilities. I'm not going to be able to utilize the decision tree features to decide for me which food is healthier. Now on to CatBoost, which is a machine learning library that can handle categorical values without having to change those categorical values into numbers. This would allow me to actually keep the high categorical columns that we have intact without converting them into numbers. So I first off apply the CatBoost train and test model on the sticky rice and 100% whole wheat bread data frames. To begin with, I assigned sticky rice to the test value and then 100% whole wheat bread to the train value and ran the CatBoost model. It will then iterate through the entire data frames and give me the best values. In this case, for Cat Boost Sticky Rice. Yay! It gave me, unfortunately, a test value of 43.257 at the 49th iteration as the best. I then switched to train and dataset values and assigned 100% whole wheat bread to the test value and sticky rice to the train value. This time when I ran the Cat Boost model, the best value was at 16.627, and it occurred at the second iteration, which is great. Then I ran the Cat Boost prediction model to predict. This time I decided to run the Cat Boost prediction model to see if it can predict the calories for sticky rice and 100% whole wheat bread. It came out with these values for sticky rice, which is within 96 to at most 97 calories. And then for whole wheat bread, it was roughly a mixture of 152 to up to 166 calories. Sadly, the Cat Boost library was unsuccessful in predicting these libraries for each of the sticky rice and whole wheat flour calories. As you can tell, calories were really 210 in sticky rice and 120 in whole wheat breads, which is completely opposite from what they predicted. As I mentioned earlier, from the USDA Standard Reference Legacy data type, I wanted to point out some points of interest, such as the nutrient list from the USDA Standard Reference Legacy, which is the SRL. Let's go ahead and look at their highest carbohydrates, and it looks like syrups is the most highest measured carbohydrates. Something I will take into consideration since my kids eat a lot of pancakes. The next value is the polyunsaturated fat from the SRL legacy. Let's see. Nuts. Obviously the picture reveals it all, but it ranked at a total of 51, followed by seeds very closely. The next is on protein. Interestingly, protein in chicken is less than 3 small scoops of whey protein. As for fiber, corn bran rules the first, followed by gums, which is, I'm unsure of that type, but it's closely followed by that. And looking at sugar and saturated fats from the nutrient list of the SRL, we can see that desserts such as mousse, chocolate, or prepared from recipe rank highest in sugars, and then they also rank highest in saturated fats. As for total kilocalories of energy, it doesn't come to a surprise that desserts, mousse, and chocolate come up as the highest kilocalories total to burn using the energy of 1818 per kilocalorie. It is followed by the second kilocalorie item, which is pie crust. Some of the lessons learned is that exploratory data analysis takes a great amount of time to synthesize. I really need to allow myself ample time for EDA, and cleaning data is a hassle. When dealing with centralized data, you have different unique values, foreign keys, and a number of varying attributes, and that's a challenge to pull together. I also learned to take the time to breathe and not overthink each piece of code that I write. I was happy enough to play with coding Python and R within a single Jupyter notebook. That was fun. I wish I could have done it more, but Go ahead and take a look at my Jupyter Notebook if you're interested. It's at the very end. What does our nutritional value in food really mean? It means we get energy from the nutrient within our food, so it's important for us to be knowledgeable on what we eat and what is in the food that we eat. Are we eating nutritious food, or are we eating what is easy, fast, and cheap? For me, I usually eat a certain type of food if it tastes good, whatever the price it may be. So I didn't get price values for the foods with my sticky rice and 100% whole wheat bread food items from FoodData Central. But that could be a future endeavor if cost was of concern. Is our food selection based on nutritional values or for other reasons? Our foods should be based on nutritional values, or at least, as I mentioned before, we all have our own dietary needs and health needs. Therefore, we should be conscientious about what we eat. The primary project question is, what if we could take the nutritional values of a type of food and then compare those values to see if our choice of food is the healthiest for us and if there is healthier options available. In fact, we did succeed at this. We learned 100% whole wheat bread is healthier than sticky rice. And, in fact, the honey 100% whole wheat bread had the lowest sugars, highest protein, and lowest carbohydrate values. It also had the lowest calories. We did, in fact, look at visualizations from my ED process and compared my findings. I also attempted to apply 2 machine learning algorithms, the decision tree and cat boost, but both were unsuccessful. So, in conclusion, where do we go from here? This project and the data within this project became a feat to overcome. It all resulted in a small data set to bring information to light on nutritional data. If time were not of the essence, I could have conducted multiple food searches to emphasize the potential of the data being pulled from FoodData Central. However, I would like to think this was a huge accomplishment. So, where do we go from here? We continue on to more conscientious food nutritional values, or perhaps what can come next is if someone can create a method that can retrieve the nutritional data through an app. Or what can come next is, could it be possible to scan the barcode on a food label and have the app return healthier alternatives? That would be neat. All in all, I thank you for watching and listening. My sources will follow for anyone interested.